All right, welcome everybody. So in this video, we will continue looking at orthogonal projections and come up with how we, given a vector u and a vector y, how we can find the orthogonal projection of vector y onto u. So let's consider the following example. We have a vector u that I've drawn in red over here. And I've got some other vector y, which in this case happens to neither be parallel or perpendicular to u. So here's some vector y. And we would like to decompose y into the sum of two vectors that we can call y hat and z. And so y hat is going to be the vector which is parallel to u. So that's this vector right here that we can denote y hat. And then we can add to y hat a second vector that we'll call z, which is now perpendicular to the vector u. So now we've written this vector y as go along some vector which is parallel to u, and then add to that some vector which is perpendicular to u, and those two vectors added up give us back the vector y. And so this vector y hat, which is in the plane parallel to vector u, this we can write as some scalar multiple c times vector u. So y hat can be written as a scalar multiple of u, and then this vector z we sometimes denote as y perp to denote that this is perpendicular to the vector y. And this vector cu, which is parallel to our original vector u, we call this the projection of vector y onto u. So we're taking this vector y and projecting it down on top of vector u. And this we can also write as the projection of y onto u plus y minus y hat. That's this vector right here, which is equal to the perpendicular piece of vector y. Okay, so we would like to go ahead and find what is y hat? What is the projection of y onto u? So we know that it's going to be some scalar multiple of this vector u, since it needs to be parallel to the vector u. And the other component, which is y minus y hat, we know that that has to be orthogonal to u. So if z is orthogonal to u, then what we know is that this vector y minus y hat, so I can write that as y minus, remember that y hat is some scalar multiple of u because it has to be parallel to u. So I'm going to rewrite this perpendicular piece, which is y minus y hat, as y minus c times u. And we take the dot product of that with u, and we should get 0, because this perpendicular piece, by definition, is going to be orthogonal to this vector u. So their dot product should give us 0. And now we can use properties of dot products, namely to say that if I've got y minus c times u inner product with u, we can write that as y inner product with u minus the scalar c times u inner product with itself. So this gives us this equation. Now if I bring this c u dot u to the other side, this gives us the relation that y inner product with u is equal to some scalar c, which is exactly the c that we need to find in order to find the projection of y onto u, times u inner product with u. So now we can solve for this scalar c by dividing both sides by u inner product with u. So now I can see that this scalar c we can find by taking y inner product with u and dividing that by u inner product with u. And that's going to tell me what this scalar c is, and that's going to tell me exactly what this blue vector is, what the projection of y onto u is. And so now let's summarize these results down below. So this vector y hat right over here, this is what we call the orthogonal projection of y onto u. And the vector z, which is right here, this is what we call the component of y, which is orthogonal to u. And up above, we showed that we can find the orthogonal projection of y onto u, which we denote with this projection subscript u of y. We just found that it's going to equal some scalar c times u, since it has to be parallel to u. And now we know exactly what that scalar is. So here is the scalar c, which is y inner product with u divided by u inner product with u. So this is the scalar times the vector u. And this tells me this component of the vector. And then once I know what y hat is, we were given y, then I can find the missing piece by subtracting the piece I just found from our original vector to figure out what is the orthogonal piece that we call z.